Good morning, and thank you again for attending another TechTime presentation. And look forward to future ones and questions coming up. So today I want to talk a little bit about superheat and subcooling. If you have any questions or down the road, send us an email. Sign up again for the next one. We do one at the end of the month on the last Tuesday. I am Jim Strandlund, part of the technical services team. Well, you'll hear from me today. My information is there, as well as our Canadian tech line and our US tech line. Phone numbers, if you're got any questions about anything that we do. We're hosted by Intertech University. Our website, intertechuniversity.com, on our YouTube channel is there. And here's some of the rest of our members of our technical services team, and a lot of wealth, knowledge, and experience here. And look forward to helping anybody with any questions on any part of their geothermal systems. In our industry, these superheat and subcooling are very important tools that we use to make sure your equipment is running right. Obviously, we start out by doing heat of rejection, heat of extraction numbers. And if we're weak, we're going to go further in to the system and look at superheat and subcooling. Superheat is defined as the amount of heat added to a vapor above its boiling point. Superheat is measured as a difference between the actual temperature of the refrigerant vapor at a certain point and the saturation temperature of the refrigerant. Subcooling is defined as the amount of heat removed from a liquid below its condensing point. Most basic meaning of subcooling is any temperatures below the saturation temperature. And generally, the lowest temperature a condenser can achieve, the better. In other words, the colder the refrigerant is as it flows into the evaporator coil, the more heat it will be able to absorb. These are like having the MRI of a human body. Okay, these tell you the nitty-gritty of how things are working. Your refrigeration gauges are more like taking your blood pressure of the piece of equipment, where the superheat subcooling gives you more finite details of the operation of the system. I want you all to remember that we have a support website that technicians and in your companies or the technicians can contact their bosses and owners and get signed up. Because inside here, as you look at the bottom, we have got documents, unit lookup, tech bulletins. All this information is available. What you'll find is a lot of this information I'm going to show you today is available in our existing manuals. So talk with your territory manager, your company managers, if you get yourselves and get your technicians signed up so they can get this information when they're out in the field if they need it. In a lot of our manuals, we have this troubleshooting chart. This is a very good tool when you're working on a piece of equipment. You've got your superheat and your subcooling measured, and it gives you a general idea of what may be wrong with your system. This is a great tool, especially when you're starting to work on trying to figure out if we have an expansion valve problem. Remember, all these charts are available in most all of our manuals. One thing to remember in the manual, look at the charts that we have here. For instance, this is for like your ZTs and ZSs. Well, they've been measured with a braze plate heat exchanger or also a regular coax. So there's different specifications, superheat subcooling numbers for these units depending on their operation. All these have been prepared by engineering testing, proven. These are the numbers that in a normal situation we should be good. So obviously there's going to be a plus or minus depending on your loop field, ductwork system, water systems and all, but this is a great place to start. Showing you the other one with a coax, the different numbers are there. So again, these are hard to maybe see, but these are available online with all our existing manuals. There's another one talking with a split unit. Okay, so the split units also have these in here showing you what possible discharge temperatures and superheat and subcooling. Pay really close attention to your incoming water temperature, entering water temperature from the loop, and make sure you pay attention to your GPM water flow. Remember, typically 3 gallons per minute is figured for a closed loop, and like 1.5 gallons per minute for an open loop. So you can use those as starting points, but there are tools and pressure gauges that you can measure and get exactly what's required. One big thing that we find in tech support, a lot of people may be putting their gauges or putting the thermometers in the wrong spots. So Intertech has these diagrams in most all of our manuals, and they're being updated and changed so we can read the numbers better. But these are very important to have, and I'm going to explain to you that I put a little package together that you'll be able to download, and I have some of the basic ones put in that the person can carry a PDF in their phone or on the job site and get a quick reference. So the neat thing about this, it actually will show your technicians or your people where approximately to put your thermometers, because that's what was the big confusing thing, depending on what mode it is, where should I have my thermometers to give me the proper superheat and subcooling numbers. So these charts will be definitely very, very helpful. And like I said, I'll have something here for you pretty quick here you can download today off of this program, which is really nice to have. Remember, again, we're going to use heat of rejection, heat of extraction numbers first to check how the unit is working. And I think the most critical one was with our geothermal split units that Intertech produces. Again, remember, they need to be charged by superheat and by subcooling. Sight glasses don't work, maybe a nice tool, but 9 times out of 10, you'll go back, it'll be undercharged or overcharged. So again, use the superheat subcooling numbers given to you in the manuals. Also available, we have a TXV troubleshooting guide through Geothermal University. And this helps some of your newer technicians that may have a little trouble experiencing or experimenting or understanding how the TXV actually works. So this gives a really good general idea how to go. One thing when this was produced, it talks about subcooling in that 8 to 12 degrees range, but check the manual because some of our other equipment may have different numbers comparative to, like, again, the entering water temperature. So use the existing manuals or go online, find the manual to get the exact specs. If you can't find them, guess what? Tech support's there to help you guys out. There's a TXV troubleshooting flowchart on the back of that program. So it's also is a simplified to help speed up your technicians, maybe follow a pathway to see if they can determine if the subcooling and superheat and the TXV are performing as expected. Now I wanted to show you, so all of these diagrams I have today, as you will see, are all available for download. And these are the 4 most common heat pump diagrams that we have in our manuals. So again, these have been put into a nice PDF package that you can download today on this program, or you can send in an email request to us or call in the tech support, and we gladly email all these data for you. I think it's a great tool to have for your technicians to carry with them in their phones or in their laptops. Now, what's really nice today when figuring a superheat and subcooling, we have tools out there, refrigeration gauges, combination units that can tell us all this stuff right as we're working on it and watch the adjustment. Field Piece makes a nice one. So does the Sporlan Parker one, all different. I personally have had the Sporlan one for years. There's a picture of my personal heat pump showing the connection where the temperature probes are put in by the expansion valves, pressure gauges are hooked up here as well. And what I like about this one, and I'm sure some of the other ones do, is that you can take a screenshot of the performance of that piece of equipment. Now, this can also be done, as this example shows you. This was my first stage of I got a WT-048 water to water unit. So this is how it was operating in first stage. And then you can take it in a two-stage unit, run it up into this as the second stage, and you can look at the performance and see how the numbers drop, how the superheat subcooling bounce around and change. Now, for some of the people that may not like all digital, I know our program, this one here, will actually get you to a mechanical gauge. So you can do either way. It actually, you can do a program curve. You can watch it for a period of time, and it will actually create a digital chart. But the greatest tool are these refrigeration set gauges that are available to technicians today. If they don't have one in their truck, they should. Makes their job faster, makes it quicker, and makes it accurate, and we make sure that our equipment is running top notch the way it should be. Other neat thing that we also have when we're trying to figure out temperature dropping or loop field or temperature, obviously, is the GeoFlow's UPC geocontroller. The variable speed flow centers are a nice program. Helps give you the details of how the performance of that is working. So the need for not having your gauges in their PT ports makes this faster and simpler, and then you can adjust and see how performance changes if you make adjustments or if you have to replace an expansion valve. So today I want to instill in you is to please remember to download that PDF file, get that to your technicians, have them carry it with you. Remember, a lot of that information is in the IOM manuals, and the testing data is in there when we can easily compare operating characteristics. Again, in tech support, we have that information that we can email to you guys as well. But technicians should have the availability to go online and find this information for themselves to make their jobs faster and quicker as well. I wanted to show you one thing today is our Intertech University channel that we have on YouTube. If you notice here, we got a section called playlists, okay? So if you click on that, it will actually show you all of the different programs we have and trainings that we have. We'll come up with a full list of the tech times or our webinars. Keep this in mind. It's a great tool for everybody to watch and to learn. And with that, I would like to say thank you for attending for another quick tech time. Again, if you got any questions, submit them to us at technicalservices@intertechgeo.com or give us a call on our tech line, and we're more happy to help you guys out. Thank you for attending. Look forward to seeing you on our next one. Have a great day.